So higher is the order of the decay, comma, the more unlikely is the decay, which means the probability is low. So this means low probability. So given the chance a nuclei prefers to decay by allowed or first forbidden decays, and higher orders are generally too weak to observe, right? So given the chance a nucleus prefers to decay by allowed or first forbidden decays, and higher orders are generally too weak to observe. So only when no other decay mode is possible can we observe these extremely rare third and fourth forbidden decays. So only when no other decay mode is possible can we observe these extremely rare third and fourth forbidden decays. Okay. So now I would again like to make the announcement, like you have quiz 2, right? On Tuesday during class time. Okay.
Okay, ma'am.
So please ensure that you have internet. Okay, you can have Wi-Fi plus data. You should have both options, whichever one works better. And plus your device also, maybe a phone and a laptop or a computer or whatever. But again, it should be properly charged and properly working. And you should always try to understand that when we're using technology, anything that can go wrong will go wrong. You remember that? Especially when
Yes, ma'am. Second law of thermodynamics
okay.
and Murphy's law.
I don't remember who exactly said this, but anyway, this is also a quotation, I think, from computer science as well. That under high stress situations, anything that you can imagine to go wrong will go wrong. So therefore, you should be prepared with redundancy, and redundancy means that if one thing goes wrong, you should have another option at the same time. Is that
Ma'am,
clear?
even Niels Bohr said something similar.
Who, Bohr? Or was it
Yes, ma'am. He
Einstein?
said,
I don't remember.
no, Bohr said nothing is certain, that everything is possible.
Okay, fine. So again, what I am trying to say is don't count on anything rather make your own arrangements, right? And also, like, Ramin took a lot of time for the last question, because maybe she was doing it on the phone. But please, if you're doing the same for your examination, then you're losing time, because that's a timed activity. Okay, so I will give you a limited time, and during that time you should be ready. And also you should ensure that if one of something goes wrong, then you have another backup option as well. Is that clear?
Yes, ma'am.
ठीक है.
Yes, ma'am.
अब तक तो I think you've had a lot of practice. This is now the third semester that we are doing this, right? So you can now prepare yourself accordingly. Okay. So this is on Tuesday during the class time, and be prepared to do it properly, right? And now we are going to go start chapter 10. Okay. This is Crane chapter 10, which is gamma decay. So we've talked about alpha decay, we've talked about beta decay. Now we are talking about gamma decay. So most alpha and beta decays and most nuclear reactions leave the final nucleus in an excited state. We've seen this, right? When we've seen this while we were studying the nuclear reactions chapter, we have seen this while we were studying the different kinds of decays. And therefore, we know that when a nucleus is in excited state, it tries to de-excite, it tries to gain stability and equilibrium, right? So these excited states decay rapidly to the ground state. And this happens through the emission of one or more gamma rays. So this happens through the emission of one or more gamma rays. So what are gamma rays? What are gamma rays?
High energy photons.
They are,
High
Photons.
energy photons.
yes, they are photons. And photons are electromagnetic radiation.
Radiations.
Yes, ma'am. Chargeless, massless particles.
Yeah. And other examples are X-rays, visible light. They all belong to the category of electromagnetic radiations. So you might remember the electromagnetic spectrum. We refer to it several times, starting from the time you started physics, maybe even before that. So this is, let's say, the spectrum, and this spectrum, this is the electromagnetic spectrum. You might have seen different kinds of illustrations. Some are made horizontally, some are made vertically. So in this case, this spectrum is divided into different parts based on what?
Based on the wavelength of the electromagnetic
Yeah,
radiation.
based on the properties of these electromagnetic radiations, and the important properties in this case are wavelength, which correspond to wavelength also corresponds to
Frequency,
frequency, and this also corresponds to
their color, and their energy.
energy. Yes, so these are all properties, characteristics, and again quantities that can be used to classify them and use them, study them, and understand them. So so these are the radio frequencies. So if we look at frequency, we can plot it here, and if we want to look at wavelength, we can plot it here, and we will see that this range is like 10 raised to minus 13 to 10 raised to minus 11 to, let's say, 10 raised to minus 9 to 10 raised to minus 7, 10 raised to minus 6, 10 raised to minus 3, and it goes down to 1, and then 10 raised to 2, and so on. So what are we seeing? We're seeing that the wavelength is decreasing as we're going upwards. Okay, the frequency we see in this case is 10 raised to 19 kilohertz. And then we see that this is around, let's say, 10 raised to 16, 10 raised to 14. You have 10 raised to 12, 10 raised to 11, 10 raised to 10, 10 raised to 7, and then you come down to 10 and 1. So what do you notice? These are decreasing and these are increasing. So this leads us to the very important and small formulas, but very important breakthrough concepts that we have had in physics, and that also led to the development and revolution in physics, leading to quantum mechanics and all that. So these were very important formula. One of the scientists, for example, who determined these relationships was de Broglie, right? So what is the de Broglie relation?
The momentum of an object is inversely proportional to its wavelength.
The momentum of an object is?
Inversely proportional to its wavelength.
Okay, great. So he was relating the properties of wavelength with mass as well, right? So again, there are many different relations, and these were very breakthrough concepts. And at the time when people were working on these, many people could not understand it. And even like, I think it was about de Broglie that when he wrote his thesis, no one could understand whether they should approve his thesis or not. And then since he had made a reference to Einstein's work, then his thesis was sent to Einstein, and Einstein, after reading his thesis, said that he thinks it's possible that this could be true, and then he was awarded his degree. So many people, when they
That's a
first...
very cool way of getting your degree.
No, actually, it's a very, his degree was in danger, because his concept was, if your concept is really a breakthrough, you don't immediately get a recognition because most people will not easily accept it. You know, it's something that's beyond the accepted knowledge of that time, and it's sometimes even contradicting the accepted knowledge of that time. And therefore there are many scientists who, instead of getting recognition, they got a lot of opposition to what they had done. So it's not always admiration that was achieved, although maybe much later it was, like Galileo Galilei is a story like many of you, I'm sure, are aware of. So when he, for the first time, challenged some ideas that were accepted, and that were, because people respected Aristotle a lot at that time, and when he disproved some of its ideas, he faced a lot of opposition, you know that. Similarly, I was reading about Boltzmann, like when he gave his concept. Boltzmann was a famous Austrian scientist, but his work could not be proved during his time, and it was not very well accepted. And he, I think, committed suicide. And later on, soon after that, his work was proved, and he got a lot of recognition. So it's not always a very happy story.
Oh, that's sad.
Well, anyway, you should not be discouraged because, also things like if it's a bestseller, it means the ordinary person understands it. If something is not a bestseller, it means it is not yet appealing to the ordinary brain, right?
Yes, ma'am.
Okay, so these are very small equations, all very simple, but these have been breakthrough equations because they relate the fundamental concepts of, just like you said, for example, wavelength with energy. We see that wavelength and energy are inversely proportional to each other. So this means that if the wavelength is low, the energy will be very high. So since we are talking about gamma rays, so their energy is high. It's the highest energy range in the electromagnetic spectrum, whereas their wavelength is among the lowest range. Similarly, you most of the part of the electromagnetic spectrum that you've been studying up till now has been mostly visible light. So most of the basic physics courses and experiments deal with normal, ordinary visible light that you can see. And again, you were talking about colors. So visible light again has is composed of a number of wavelengths, and these wavelengths, uh, correspond to a specific color, and so there it gives a spectrum which is a spectrum of the rainbow. It starts with something like this, red, orange, and it ends with violet. So you would have this spectrum over here, you would have violet color here, you would have red color here, and in between you will have the remaining colors. But this is something the human eye can detect. The rest of the radiations, the human eye cannot detect them, but they are again very useful, and from the physics point of view as well as from the applications point of view. So you know that, for example, infrared radiation has its own applications. UV radiation has its own applications. X-rays is a huge field. There are many Nobel prizes that have been awarded to this. This was discovered by a German scientist who was called Röntgen. So in German language, they don't call it X-rays; they call it Röntgen rays, right? Röntgenstrahlung. And again, this field continues to develop in many areas, including fundamental physics as well as application physics like medical physics, imaging, and so on. And both from the theoretical point of view and from the experimental point of view. And then gamma rays, again, gamma rays have a lot of applications and uses. And these are very high energy radiations, and this means that they are very penetrating as well. And they are also used in a variety of ways for different kinds of scientific studies, experiments, as well as application fields as well. So it's an interesting radiations. So when you study the basic properties of radiations, you see that they are basically photons. So they have the properties of photons, but then their energy is very high, and hence they're very penetrating radiations.
एक्सक्यूज मी मैम।
Yes.
मैम शर्जील का भी मैसेज आया है कि उसकी तबीयत नहीं ठीक, इसलिए वो क्लास में नहीं आया। उसने कहा मैम को फॉरवर्ड कर
अच्छा,
दो।
मुझे पता चल गया है. So give him my best wishes, okay?
ओके मैम।
हाँ, I hope he gets well soon. उसको कहो अपना ख्याल रखे, get himself treated so that he can join back. ठीक है? And take
ओके
rest.
मैम।
अच्छा, so gamma rays energy, like we were just talking about. So I'm talking about Crane, page 327. So this energy ranges from 0.1 to 10 MeV. So you see that the units of energy that we are mostly using in this subject are in MeV. right? So again, you know how to convert back and forth. So in terms of wavelength, it's from 10 raised to 4 to 100 femtometers. So again, this energy can be used as a defining feature, as a characteristic of the energy difference between different states. So this energy can be a characteristic of the energy difference between nuclear states. And as we already discussed with the help of the spectrum, these wavelengths are far shorter than those of the other types of electromagnetic radiations that we normally encounter. We saw that they were towards the very low wavelength part of the spectrum, and which corresponds to the very high um, energy or frequency part of the spectrum. And again, I wrote the equations that help you convert from, let's say, wavelength to energy and energy to frequency, and so back and forth. So nuclear spectroscopy is another branch of physics, and this depends on our knowledge of the excited states. So therefore, gamma ray emission has become the standard technique for nuclear spectroscopy. Like I told you, there are many different kinds of applications. So nuclear spectroscopy is one of them. Okay, so other advantages, what other advantages can we have? There's a relative ease of observing gamma rays. So we have now devices and instruments, and it's easy and possible for us to observe gamma rays. Of course, you cannot work with the radiation if you cannot detect it. So we have the detection systems for this. Again, there is a chapter on the detection of radiation. So we will see if we have time to go there. So the negligible absorption and scattering in the air. And for instance, contrary to the behavior of alpha and beta rays, alpha and beta radiations, are very easily absorbed. But gamma rays have a longer penetration length, and that's very useful for some applications. And also accuracy with which their energies can be measured. So we have accurate methods and techniques for measuring their energies, and this can therefore lead to more useful applications and experiments. Okay. Okay. And studying gamma emission and its competing process which is known as internal conversion allows us to deduce the spins and parities of excited states. Now you can see how these values that you have in your table, for example, could have been obtained. Okay. So now we will be going to the next topic, but I think we should start it in the next class, right? So this was an introduction to gamma radiations. We will start the next class from here. But again, I remind you on Tuesday, you have the quiz during the class time. Okay. And the date on Tuesday is the 26th.
मैम एक दफा क्विज का सिलेबस बता दें
सिलेबस बेटा जो पढ़ा है वो आएगा उसमें आज तक का जो पढ़ा है
लाइक मिड टर्म से पहले वाला भी
बेटा एक्चुअली इट्स ऑल इंटर रिलेटेड कौन बोल रहा है वैसे
दुर्दाना
दुर्दाना हाँ आपको पता है कि हम फॉर्मूलाज जब यूज करते हैं कॉन्सेप्ट्स यूज करते हैं it's difficult to cut it off because I'm not going to give you something to memorize and to reproduce. If I give you a problem to solve, it could use a formula from any chapter, right? So therefore, I would say the syllabus is what we have studied. ठीक है? Okay, so I would like to take the attendance once again. So, Tahreen.
Present, ma'am.
Okay, and Asad.
Present, ma'am.
Durdana.
यस मैम
Ramin.
Yes, ma'am.
And just a moment. अच्छा एमन अक्सर जो है ना सेकंड पार्ट में नहीं होती सेकंड मीटिंग में अक्सर वो मिसिंग होती है सो शजील इज सिक ओके चलिए ओके थैंक यू टेक केयर
Allah Hafiz, ma'am.
अल्लाह
Okay,
हाफिज
ma'am. Bye-bye.
बाय बाय